Let's look at a cylinder on its side. We'll go cylinder on side. Cylinder on side, so upright cylinder used 1 point perspective. One point, what? Cylinder on its side is we're gonna use 2 point perspective because you end up with a more natural cylinder that way. So I'm gonna say there's a vanishing point here. These are arbitrary, by the way. I'm not gonna use this one that I used for this cylinder. I've got a new set of vanishing points. This cylinder is gonna be on its side somewhere here. So let's just run this back to the vanishing point. It's probably not quite enough. I'm going to intuitively find what feels like a square to me, and it's on the side. There are mathematical ways to do this in perspective, but I don't want us to dig into those so much. We're just going to do something here that's not as wide as it is tall. So it can't be wider than it is tall. It has to be crunched in a little bit, but something like this will give us what we need. Run this back. Basically going to build a transparent box again. Let's say it's that long. Split the difference between those. So here's my box this cylinder is going to live in. In order to find my cylinder, or my ellipse end, I'm going to find the center of the end here. This is that dividing trick again. So I need an ellipse that passes through there, 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 and there. I'm going to find the back end as well. So I'm going to divide this plane. Vertical and the vanishing point. That's dead center. This ellipse has to pass here, 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 and here. All right, the important bit here now is between the centers. If we look from the vanishing point between center and center, we have this. That is the new axis of our cylinder. So in this upright cylinder, the axis is perfectly vertical. In our 2-point perspective cylinder, the axis runs to one of the vanishing points. Whichever vanishing point is relative to the ends of our cylinder, then its axis runs to that vanishing point. That's important because in order for the ellipses to make sense, they need to be 90 degrees. They need to be oriented. Their minor axis, and you remember that's the short distance. If I have an ellipse, its minor axis is the short distance across it. That needs to be 90 degrees to this axis on its way back. So what that means is I can't put an ellipse in here that goes like this, that's oriented like straight up and down. It has to tilt slightly so that it's 90 degrees to that axis, which if I look at my marks here, it's not quite, my cross line here is almost 90 degrees, but not quite. My ellipse is gonna touch, it's gonna touch here, but it's gonna kind of be oriented this way. I'm going 90 degrees to that axis. So I'm going to ghost it there, and I'm going to do the same thing over here. Just trying to run it through these points the best I can. I'm building a map for myself here. So then I'm going to come off. That's a little bit flat at the bottom there. Not a little bit, it's actually quite flat at the bottom. It needs to curve off a bit. So that's going to be the ends. I'm going to connect the tops of those. They should connect across some line that runs from one end of one ellipse through the other end of the other ellipse. Gives me the edge of my cylinder. If I want to clean this up, I can go through and erase anything that's not part of the cylinder. For our drawings, this may look sort of like messy, like all of this diagramming, but I actually want us to keep that. I like to see in the drawings this sort of dissection and buildup and deconstruction of what you are drawing. Every drawing doesn't have to be pristine and perfect. We can get there later, and if that's your aim, you can definitely get there as part of the process. But for us and for our drawings, I like to see these sort of erasing, sort of the way you constructed this thing. Okay, so that's a cylinder on its side. And you can see these ellipses, they tilt 90 degrees to that axis that goes back to the vanishing point.